Okay, so hello and welcome back, and this is Chipmaster, and in this video I'll be doing another repair on a laptop here. It's a, you can call it a gaming slash high performance, right? It's a Asus Republic of Gamers, right? It's a ROG, beautiful laptops, right? It's a bit big and heavy, and they told me that it's not turning on. So as you can see, it seems as if it's a 17-inch, right? Republic of Gamers, right? ROG Strix. Alright, so I'm going to get the power. Okay, so this is a very large computer, it takes up almost my entire desk space. As you can see, very big. Right, so I'm going to plug in the power. So this is my power supply, right, because the tip here is unable to connect to my DC power supply, so I wired a ammeter on the charger to see the voltage and current, right? So this is what I'll be working with for the rest of the video, because I'm unable to use the DC power supply to connect this tip. So I use the regular charger and just tapped in on the circuit here on the series. So this is a part of the circuit that you know how an ammeter works, so I can see my voltage and current, right? So I'll have to show you this at all times. Alright, so as you can see, I plug in the charger. I'm not taking any current. Alright, so I'm pressing the switch. I think I'll have to get a camera for this instead. Alright, so this is the switch. As I'm pressing the switch, I'm not getting anything. As you can see, there's nothing going on there. No current. Alright, so I'm going to take apart the unit. Sorry about that. Very huge laptop. This is a AMD. Doesn't state on the palm rest if it's an AMD or an Intel. It seems as if it's an AMD because I'm not seeing a PCH. Normally the PCH would be on this side, right? The CPU and the graphics card. A lot of screws. Alright, the heatsink is finally off. So this is an AMD CPU with the AMD Ryzen 9. Let me confirm. Yes, Ryzen 9. Right. This is a Ryzen 9 base CPU. X3D series, I believe. Beautiful CPU, powerful CPU, the latest, and it's already dead. As you can see, I have liquid metal here, right? So I'm going to put some tape over this because I don't want it to spill. This can cause serious problems for me because it's very conductive, right? So I normally use masking tape. Right, and I will mask the area. So that when I'm working on the board on the other side, if I flip the board, then this will mess up my workspace, and I don't want it to touch the board because it's very difficult to clean. Okay, just checking my fingers if any caught my finger. Alright, so the board is out. Now I can work. The DC jack is already on the board, so I don't need to think about desoldering. 745. Alright, so I'm gonna check for some resistances. Alright, so this is the current sensing resistor. I have a dead short, as you can see. It's also, you hear that buzz? So I have a dead short to ground here on the 19 volt rail. And I get 6 that indicate that maybe one of these DR MOS is broken in it. It seems one of these DR MOS is broken. It's not that low to ground. Alright, so let's check the standby. This should be standby 3 volts and 5 volts. I get 165. The other one side I get 514. Oh, this is 3 volt and 5 volts. This should be for the charging. Yeah, this is the charging. Right, this is 3.3 volts. I get 384. Right, this should be for the second 5 volts. So there should be 2 5 volts, right? Reason, because of the type C ports, right? So the type C ports need that 5 volts for the USB on the go. So after pressing the switch, this 5 volts will generate to power the 2 USB C ports, which is called OTG, right? USB on the go for the OTG, and this is normally controlled by our charging chip, right, which is going to send an enable signal to turn on this 5 volts so it can power the USB ports, while this 5 volts is for powering other chips and other devices and for use for the secondary conversion power supply for your hard disk and so forth, right? We call that run voltage for the secondary supplies. So this is why if you are working on a motherboard and you see two 5 volts, right, one is for OTG, right, so most likely you have a type C port on that motherboard. So if you see if you see two 5 volts, immediately look for type C ports, right? So this is the architecture for the OTG USB on the go, and you will see two 5 volts, right? If it's a case where you only see 5 volts but no 3.3 volts, that indicates that you need the battery to be present in order for the board to be triggered. If the battery is not sensed, then you can't get a trigger even if the adapter is plugged in, right? So you need to know the architecture of this board. These types of new board, it's a way of we call it the ACPI architecture to conserve power consumption, especially on these laptops that consumes a lot of power, right? All right, so I have another coil here. Oh, this is the charging coil. So this one, I'm not sure. All right, this is an AMD Ryzen, so we need VDD with 3.3 volts. Right, so we need VDD 3.3 volts, VDD 1.8 volts, VDD-P, and VDD-CR SoC underscore S5, right, and RCM reset and the power button, right? RT and 32.768 kilohertz, right? Those are only the working conditions. So you need to know for the AMD platforms. Since the AMD platforms are much simpler than the Intel, right, because of Intel management technology, right? So you have to know just these few working conditions in order to get a trigger, right? So once you plug in the charger, all these power supplies must be generated, right, in order for you to get a successful trigger, right? So that's the order. All right, so this coil, I get 468, bias chip pin number 8, I get 386. This should be VDD-P. All right, 383. All right, this is another one, VDD-CR, 0.9 volts, 0.7 volts, sorry, 3.7 volts, right? And we have here the graphics card, right? That's good, and that's going to be all for these phases. Same, see, right? This is for the graphics, for the video memory. This should be for the VRAM. This is the VRAM 159, right, to power the VRAMs for the NVIDIA, right, video memory, right? This is for the CPU core. I get 29, right? So that this is basically giving me a clue that my CPU core is not shorted because I'm getting 6 here, right? But here I'm getting any of these rails. Oh, so this is 1.8. This should be 1.8. I get 3 here, 4, and this one is giving me 6. So 4, 6. So there's a difference. Yeah. All right. So based on my observation, I don't think any of my DRMOS chipsets are burnt. Right. So I'm just removing the silicone. I'll have to reapply some fresh ones after I'm finished. All right. So I'm looking to see if I see any burn, any explosions on the DRMOS. And I didn't even inspect the board. Oh, I forgot that. Alright, so these are the DRMOS, and I'm not seeing any burn or any explosion on them. Right, so these are DRMOS, meaning that they have integrated MOSFETs and they are controller driven by a PWM IC, which is this chip here. This is the CPU PWM. So this chip controls all of these. Right, so there are 1, 2, 3, 4, 5, 6, 7, 8 of them. Right, 1, 2, 3, 4, 5, 6, 7, 8. Right, this is for the graphics card, VRAM. Right. Alright, so I'm not seeing any burn. Let's take a look at the ones for the graphics card. just using my finger, or I can just, for safety, I just use my napkin here. Alright, looking at them, they are all good. Not seeing any burn, any explosion on the DRMOS. And this is the PWM control chip, right? And that is used to control these, all of these, right? 0.8 volts for the graphics card, right? And this one should be for the VRAM. This is another PWM chip which is going to use to control the VRAM, right? This is most likely for GDDR6, right? These are GDDR6 RAMs, right? And the brand is Micron, right? The brand is Micron, as you can see, right? So this is the code number. If you look up this code number, you can see the size of it, right? And also the type, which is a GDDR5X or GDDR6X, right? But this is not the focus of the matter now. We need to find out what is shorting, right? So I'm just doing a visual inspection, as I said before, on the DRMOS, and they're all good. Now I'm going to take a look at the back side of the board. Right, so as I'm moving this sticker here, right, these are all TAN capacitors, right, which is outputting and filtering smooth 0.8 volts for the CPU and for the graphics card. Right, so one set is here for the graphics card, another set is here for the CPU. I'm not seeing any burn, any explosion on this side of the board. Right, so I'm checking here, visual inspection, cleaning off the dust. Right, so as you can see, this is the power delivery chip for the Type C. So we can use both Type C, or you can use the charger, right? But most likely this is for expansion, right? Because this has the MUX, which is this chip, which is used. This is basically a timer, because it can process image signals and it can also convert the signals. So it processes and it drives the image or data signals. Right, as you can see, Type C, right? So these chips are for the Type C. So this is the MUX, right? And this one is for the power delivery, right? ITE, and this is another brand, which is ASM, which is used by Asus. This is another brand of, this is for USB MUX, right? To transmit. This is a retimer, right? This is a retimer, so it can process, right, and accelerate display and other signals such as HDMI signals, all different types of signals, right? And this is a differential signal, so this is a retimer, right? A redriver only can accelerate, but it cannot process the signals, right? So this is a retimer. All right, so I'm going to head over to the thermal camera because there's no burn, right? So I'm not sure what is causing the short, but I'm getting a short here, as you can see. 6. All right, so I'm going to, and I plug in the charger before, and I was not getting any current draw. Right, so I plug in the charger. As you can see, I'm not getting a current, right? So that indicates that the voltage is not passing. So there's no way I can use this to detect the short, so I'll have to inject. As you can see, I'm getting 0, 0, 0. There's no current draw there. All right, so I'll have to head over to the camera. All right, so I will okay, so I'm on the thermal camera and I'm going to first check in this area here, which is the CPU and the graphics card. because these are most of the time the places where normally have these broken components. Even though I tested with the multimeter and I was getting a different reading on both sides, so I'm actually inputting roughly 2.8 volts at the moment. Alright, so I'm gonna give power. Not getting anything there. Alright. Not getting anything. Not getting any current draw. Very interesting. Alright, so I give power but I'm not getting anything. Alright, so okay, so I am going to increase the voltage to about 5 volts. Right, slowly. Alright, so I'm going to reseek. Alright, so I'm giving power. Alright, so I'm getting something now. What is that? What is that? I see a heat spot right here. So one of my DRMOS is broken. Alright, so I'm going to give power so that the cursor here can point and tell me which one of them is having a break. The cursor is actually, let's see the temperature again. 30-40 degrees, and it's pointing directly between this part. So that's which one of them. Let me confirm again. So it's 1, 2, 3, 4, 5. Between the fifth and the sixth one. Alright, so that's between the fifth and the sixth one. So that's 1, 2, 3, 4, 5. So it's somewhere here. Let me see under the microscope. All right. So it's between the fifth and the sixth one. So let me see. That's 1, 2. There go again. That's 1, 2, 3, 4, 5. I see some small caps here under this cooling silica. You can call it silica gel. Something like it's a silicone for thermal cooling. Alright, so I'm going to use the brush here to remove the excess so I can see if it's one of these capacitors are causing it. Alright, 1, 2, 3, 4, 5. Alright, so I'm going to put some 99.9 while giving power to see if it's this. Alright, so I'm giving power. Alright, I'm going on to the next side just to make sure. Oh, here is it. So it was under the other side of the board. Look at this gap here. Here is the culprit. Here is this. Here it is. As you can see, it dried the alcohol very fast. So that is the culprit there. So I should have turned over the board, and I should be able to see clearly, because most of the time the DRMOS chipsets are always short broken, and they, due to high frequency and switching during work, they break. So in my mind I was thought, hey, this seems like it's a DRMOS, but it actually was a capacitor. Oops. Alright, so I'm removing it. There we go. It's now out of the circuit. I need some hot air heat on this to completely remove the remains of this cap. There's a slight corrosion that caused it, as you can see. Some of the solder, the mask of the board is stripping off and exposing. Right here, as you can see. Right, so this was a liquid, a slight liquid in mildew. We can call it a mildew. Sorry. All right, there we go. All right, so I'm going to put a new one there. This is a 06. This is a 0805 capacitor, right? You can put a 330 microfarad there, right, to 25 volts, right? 330 microfarad, 25 volts, 0805 capacitor, and here is it, brand new in the lot. All right, so I'm just going to take one out and put it there. Beautiful. All right, so I'm going to solder this one in. And I'm going to check the adapter input MOSFET, because that MOSFET most times get a reverse feed due to that short, and it sends back a surge because there's a body diode that's inside of that MOSFET, which is used to prevent, which is called reverse bias MOSFET, to protect that surge from going back to the charger. Right, so that's why it's called an isolation and protection circuit. So it protects the battery and isolate the charger voltage from the battery voltage. But for most newer motherboards, these voltages are called hybrid. As you can see, this board is very thick, so I'll have to increase my temperature because of the layer of this board is designed to take a lot of heat, because this circuit, this type of circuit, we call it the Darlington circuit, which takes a lot of power and current, hence it will get very hot. So the board will have to, you have to manufacture this board with more layers in order to withstand the amount of heat that is going to be generated during the workflow of the dynamic adjustment of the CPU and the graphics card power supply. Alright, so this is why I have to turn up my hot air temperature to roughly 400 degrees, 420 degrees rather, because this board absorbs the small the small amount of temperature, which is normally like 350 to 380 degrees. It's very difficult to remove the chips of these types of boards. Right, so I'm going to remove the current sensing here, and I will now check the input MOSFET. Right, these are your input MOSFETs. Alright, the board's input MOSFETs, and it is used to protect and to isolate any foul play that can occur on this line, so it don't burn your charger. Right, so this is your This is your adapter MOSFET, and this is your reverse bias MOSFET. Oh, sorry, let me get my multimeter. Okay, so sorry about that. My multimeter was not on screen. All right, so I'm going to check now on the current sensing. As you can see, I now have 371, right? I have 373.5, so all is well there. Alright, so I'm going to check the reverse bias MOSFET. Alright, so as you can see, I'm not getting a shower. Alright, let me reverse it. I get 448. Excellent. I'm checking the other one. Alright, that's good. And there's no short. 477, 476. So there's no short. So the MOSFET didn't get a hit. Right? So I'm going to connect the power now. I'm going to connect the power now and see. Okay, so as you can see on the meter here, so I can have a hands-free hand. Oh, sorry about that again. Alright, so I'm going to plug in the power now. Alright, there we go. We have 150. We have 15 milliamp now. So I should get 3 volts and 5 volts. Alright, so let me see this one. Sorry, I'm on alright. So this coil, I get 2.7. This one, 5 volts, right? So remember we said that we're supposed to be having 2 5 volts. Let's see this one. Let's see this one. 1.5 volts. 5 volts. Here is it. So one is for. So this is the main 5 volts. Right. This 5 volts is for the on-die termination. Right. So I get 5.1 volts. As you can see, the voltages are the same. Right. So 3.3 volts should be here. And as I said before, the 3.3 volts should be sensed only when the battery is present. Right, let me see if I can get some more length. All right. See, right. So as you can see, I have 5 volts, right, and I'm not seeing 3.3 volts. So 3.3 volts is here, right? But as I said before, the 3.3 volts will only be present after pressing the switch. So let me confirm the power switch on this laptop. Most likely it's on the keyboard. Yes, it's inside of the keyboard. So I'm going to manually turn it on with my multimeter here to see if I get a trigger. It turns on. So it turns on. As you can see, I get 1.7 amp there, 1.8. All right, so the board is triggered. Let me come out some more so I can give you a better view. All right, good. So we can see the current meter. Okay, so As you can see, I get 32, 31, 32 milliamp, right? And I get the 5 volts, which is for our OTG, and 5 volt standby. 3.3 volts is only after the switch, right? So with this board, it doesn't need to sense the it doesn't need to sense the battery to turn on 3.3 volts. All right, so let's go again. Sorry. There we go. So 3.3 volts is here. All right, I have 3.3 volts there. Excellent. All right, I have, it's off. All right, there we go. Switched on. All right, this coil. All right, it's not staying on. So as you can see, I need to get my heatsink. So I will connect the heatsink. Okay, so because of demonstration purpose, I'll use my heatsinks here. One for the CPU and one for the graphics. Okay. All right, so I'm going to give power. Right, so as you can see, I have the first 5 volts here. Right, this is main 5 volts, OTG 5 volts, no, main 5 volts, right, OTG 5 volts, right, 3.3 volts after the switch. Right, normally, as I said before, after sensing the battery, then it will trigger. If not, you can't get a trigger, right? But I realized on this board I can get a trigger even though the battery is not sensed, right? So I need to find 1.8 volts and 0.7 volts, which is VDD 1.8 volts always, and VDD-P, which is about 0.7 volts or 0.8 volts, right? So I'm checking here, no voltage there, right? There are some small circuits with some small coils. Let me see here, right? No voltage here. Let me see this one. All right, nothing there. Let's see this coil. Nothing there. I get 5 volts. Yes, I get 5 volts. Still have my 2 5 volts. All right, not getting anything there. So most likely is after the switch. So let me see if I can trigger. All right, the board is triggered. Nothing there. I get 1.8. Here it is, VDD-P, 0.7 volts. It's powered off. It's powered off. All right. So well, as you can see, I got the main rails that I needed. Right, so I get 1.8, 0.7 VDD-P. All right, 3.3 was already measured. All right, so everything is good. So I'll now assembled the unit and be right back. Okay, now so the unit is now assembled. Well, I just put the board. I haven't put the back cover. Right, so I will now give power. Alright, so as you can see, the current is now showing me 100, 300, 34 milliamps, sorry. Right, so I'm now pressing the switch. There we go, we have lights on the keyboard there. And I'm taking 9 ampere, as you can see. 9 ampere. It's now back to 7, and as you can see, I have display. All right, so all right, there we go. So as you can see, the battery must be present in order for it to turn on, because without the battery it turns on for a few seconds and power off. So my explanation was correct. Because of the on-die termination, the OTG, USB on the go, right? All those features, the battery must be sensed, right? So if the battery is not sensed, it will turn on and turn off, right? So that is why it was turning on for a few seconds and turn off, because it needs to sense the battery in order for it to complete the power on cycle. All right, so there we go. So as you can see, the unit is basically seems as if it was doing an upgrade there. All right, so I'm going to leave it as is. All right, so and that's a done job.
To set up your device using a
Yeah.
turn on narrator by
As you can hear, Microsoft narrator. All right, so I hope you enjoyed.
Or select the accessibility icon in the bottom corner.
So I hope you enjoyed the video. Hope you learned something, and in the next video I will definitely do another repair for you. All right, so see you again. Bye.